Hello everyone. So today we are going to solve a problem from LeetCode daily challenge, permutation in string. So let us read the problem statement first. Problem statement is pretty simple. Uh, we are given two string s1 and s2 and we have to return true if s2 is s2 contains a permutation of s1, and if it does not contain, then we have to return false. So let us first understand the permutation first. Permutations is nothing but the rearrangement of characters, and as we can see here, there are six permutations of ABC. Let us take this input and understand this. So I have taken one input here, and this S1 is ABC and S2 is EIDBACOOO. So we have to find, we have to return true if if I find any permutation of S1 as a substring in S2. The brute force approach would be nothing but checking all the permutations. First of all, I will generate all the different possible arrangement of string for ABC, and as we can see, I've already generated all the possible arrangement of ABC, and I can check in this S2 substring by generating all the substring of S2, and we can check by comparing it that whether it contains the permutation of or not. As we can see here, BAC is one of the permutations of ABC, and in this S2 substring also, uh, in this S2 string also, we contain BAC as a substring, so we will return true here. And similarly, in example 2, we will not find any permutation of AB in this S2 substring. The time complexity of brute force approach would be very high, because for generating all the permutation, order of n into n factorial complexity, and for checking all the substring and generating all the substring, we need a time complexity of order of m cross m, because m is the substring, or m is the length of s2 s2 string, and n is the length of s1 string. So we will generate all the permutation of s1, and we will generate all the substring of s2. So overall time complexity would be order of n cross n factorial cross m, which is very high. So we will not go with this approach. As we can see here, the constraint is very high, 10 to the power 4, so it will not pass. This solution will not pass. So we need to think some more optimal solution. So let us have some observations. So the key observation here is permutation is nothing but the rearrangement of characters. Also in permutation, you can observe here that the frequency of all the characters in any particular permutation is same as any other permutation of that particular string. As we can see, the frequency of a in all the permutation is 1, and b in all the permutation is 1, and c in all the permutation is also 1. So the frequency will remain the same, no matter how many different permutation we generate, but the frequency of the permutation will remain the same. So this is the observation. We don't need to generate all the permutation of ABC. We just have to match the frequency of length of s1 with any of the substring of length of length of s1 in s2. Let us see this by an example. As we can see here, we have ABC. So here frequency of A is 1, B is 1, and C is also 1. So we'll check the first three character whether we got the same frequency as the character of the string in S1, and we can see the frequency of A, B, and C doesn't match here. So we'll not consider this, and we will take again the next window IDB, and we can see here frequency, still the frequency doesn't match. So we'll move forward dba, still the frequency doesn't match. And if we come at this point bac, we can see here that the frequency of this window bac and abc matches. So we will return true here. So the problem boils down to checking the frequency of characters in a length in S1, and comparing that to to a substring of S2 of length S1. We just have to check for every S1 length string, S1 length substring in S2, whether the frequency of these character is same as in the S2 or not. And if and at any point of time we'll find the frequency same, we'll return true, otherwise we'll return false. So let's move to the code part now. We will first take the variable n1, which will store the size of the S1, and n2, which will store the size of the S2. And the edge case here, if we are given the size of n1 is greater than n2, then we will never have a solution. So we will return false here. Suppose we are given a string s1 as a, b, c, d, e, and s2 as a, b, c. So we will never find a solution here, because like the S2 length is less than S1, and A, B, C, D will never be present in this S2 because the length is smaller. So in no matter what we'll do, we will not find the characters here in S2. Now I will take a window size of S1 length. And I will take two vector. First vector will contain the frequency of characters in S1, and second vector will contain the frequency of character in S2. So I will name it as frequency S1, which is of length 26 character, and frequency S2, which will also have length of 26 character, and initially the frequency of every character is 0. So I will fill it with 0. So first I will have the frequency of character in S1. Frequency of S1 of S1 of I minus A, and I will increase the count of the frequency. And now I will calculate the frequency of window size in frequency 2. So which will window size minus 1 I plus plus, and it will equals to frequency of S2 and S2 of I minus A plus plus. Yeah. And here the sliding window will start. I will perform this from window size minus 1, and it will be equals to less than equals to n2 and I plus plus. So again when I will come here at window size minus 1, so basically what I'm doing here is I have taken the frequency of ABC in frequency S1, and in frequency S2 first I will calculate the frequency till here, till S1 length minus 1 till here, and from this D, what I will do is I will increase the frequency in frequency 2, and subsequently I will also decrease this frequency of E also, because like in another iteration the frequency of B will increase and E will decrease. So from here I will subsequently do the same for every character, and I will increase the frequency s2 of s2 of I minus a plus plus. Yeah, and I will have a check function. If I will do something in this check function, and I will check if the frequency of s1 is equals to s2 or not. So I will pass frequency of s1 and frequency of s2 in it, and if it is true, then I will return true, because like I have found that s2 contains at least one permutation of s1. And if not, then I will continue this sliding window, and I will decrease the frequency of s2, and I will also take one previous index which will initially equals to 0, and this previous index uh, minus a, and I will decrease the frequency as we have seen here. uh, to maintain a window, we have to decrease the frequency of the previous index, and increase the frequency of the next index. So this is what I'm doing here, and also I will increase the previous index here, index value. Yeah. So if in the whole substring I don't find anything similar in the frequency, then I will return false here. So the remaining part is to have the check function. So I will have a check function here, which will have two factor, and I will pass it as a reference, not as a copy. Frequency of s1 and vector of frequency of s2. This should be also as a reference. Yeah, and I will run a loop of 26, and I will check if frequency of s1 is not equals to frequency of s2, then I will return false here. And if this statement doesn't become true, that means every frequency of our string in this s1 is equals to every frequency of s2. So I will return true here. I hope this should work. Let us run. This should be s1. There should be a semicolon here. Yeah. So as we can see, it's accepted. So this is for this problem. Feel free to comment if there is any doubt. See you in the next video. Thank you.